right, in this podcast, we're going to do some practice problems, not only taking names and drawing structures from them, we're also going to take structures and name them to give you guys a little more guided practice. The problems that we're working are going to come out of your Chem 1211 guided practice as well. All right, so when we have a drawing like this, the first thing that we need to do is we need to make sure that we are finding the longest chain of carbons, or the parent chain. In this case, we have a cyclic structure or a ring, so that automatically gets to be the parent chain. So my parent chain is 5 carbons, and we know that 5 has the prefix pent. So I'm going to begin writing this as having a parent chain of pentane. Because it's cyclic, I also have to include the prefix cyclopentane, and that's all one word. It just doesn't look great because my handwriting's not fantastic. All right, so we've already identified our parent chain, so we are done with that. Now we identify anything that's not part of the parent chain. So we have 1, 2, 3 different groups. So we're going to have to figure out how to number the cyclic alkane in a way that gives most of our groups the lowest number carbon possible. Because this is a cyclic, we can start counting at any point in the ring. We kind of get a choice there. So I have a couple options. I can start counting here with my 2 methyl groups and go all the way around. Or I can start counting with my ethyl groups. 2, 3, 4, 5, and go all the way around. If I use the green numbering scheme, I will have 2 groups in the 1 position and 1 group in the 2 position. If I use the red numbering scheme, I'm going to have 1 group in the 1 position and 2 groups in the 2 position. So I'm going to go with the green numbering scheme because this gives me more groups at a lower number carbon. All right, so the groups that I have are an ethyl, that's a 2-carbon alkyl group, and I also have I actually have 2 methyls, that is a 1-carbon each alkyl group. Because I have 2 methyls, I will need to name them di. When I put these into the name, it is alphabetical, so we go alphabetical by the first letter of the branch. So we would say M, even though there's a di on front of it, you kind of ignore the di and you go by the first letter of the branch name. So we have ethyl E or methyl M. Ethyl comes first in the alphabet, so I'm going to start by numbering. This is in the 2 position, to ethyl. And then I have to state the number for each of my methyl groups, even though they're on the same carbon. So this is going to be 1, 1, di, methyl, and this isn't going to fit cyclopentane. All right, so things to remember on a structure like this is that you can start numbering anywhere, and you want to give all your branches the lowest number of carbons possible. And then when you name it, you want to make sure that you are naming the branches alphabetically. We don't include di or tri when we are naming them. We go by the first letter of the branch name. All right, this one should feel easy after the last one. So we're going to start with the parent, which is the cyclic ring. And it is 1, 2, 3, 4 carbons long, which is butane. Because it's cyclic, we need to put cyclo on there. And I am going to count around the ring so that we can number our branches. 1, 2, 3, 4. And these guys are in the 1, 3 position no matter what I do. So I could count the other way just to make sure that that is correct, or I could just trust. So I have 2 chloro groups, 2 chlorine groups. So this would be dichlorocyclobutane. And I have to also make sure that I'm addressing which position those chlorine groups are in. They're in the 1 and 3 positions. I use the di to say that I have 2 chlorine groups, and it is on the parent chain, cyclobutane. All right, so now we're going to take a name and we're going to draw a structure from it. And so when doing this, I always like to start with the parent chain. We have bute, which tells me it has 4 carbons, and ane tells me it's all single bonds. Cyclic tells me those 4 carbons are wrapped up around into a cyclic structure. So 4 carbons looks like a square. It is a cyclic structure. So we've taken care of our parent chain. Now we need to address where our different groups go. And it doesn't matter where on my drawing I put those groups because I can start numbering at any position. So the name tells me I have an ethyl group, which is eth is 2 carbons, and a methyl group, meth is 1 carbon, not carbons. All right, so in the 1 position, I'm going to put CH2, CH3, that is an ethyl group, and in the 2 position, I'll put CH3, which is a methyl. So here I have 1 ethyl, 2 methyl, cyclobutane. All right, so let's start where we started before, and we're going to look at the parent chain, which is cyclohexane. So that tells me I have a ring structure. Hex tells me I have 6 carbons, and they're all single bonds. So I'm going to draw a cyclohexane, and they don't give me a number on here. If you only have 1 branch, it's not necessary to number because everybody knows you're going to automatically assign it to carbon number 1. So I can pick that position wherever I want and add a methyl group. So this would be methyl cyclohexane. If you forget and accidentally number it, that's okay. 1 methyl cyclohexane would be okay as well.